All right. We might kick off our first of our Ask a Researcher webinars. So thank you everyone for joining us today. It's great to have a few people joining us online. This session is the first of an Ask a Researcher series that we're planning on running this year as part of getting to know the researchers within DairyBio and Dairy Feed Base. So this session, we've got research scientists Dr. Fong Ho and Dr. Joe Newton joining us. So Fong and Joe have been in this hot seat before. So there used to be a series of Ask a Researchers back in COVID times in 2020. So both Fong and Joe have sat in this hot seat before and talked to us about their work. And we thought we'd go back and revisit what they've been doing. They work on predicting fertility within herds and looking at the fertility potential of cows. And so I thought we'd spend some time talking with them about what they've done since 2020 and how they are helping us as farmers. So welcome, Fong and Joe. It's good to have you both here. Let's get started. For those who missed the webinar in 2020, we are talking about a new technology, MIR, fertility prediction. Now, I'm not even going to try and pretend that I know exactly what that is. So Fong, I might ask you, can you just give us a rundown? What is this technology and how can we use it? Or how are you, gone about developing it?
Yeah. All right. Thanks, Liz, for the nice introductions, and hi, everyone. So firstly, I probably have to admit that this is not a new technology, but it's a new potential. So I guess for quite a number of you here, I think you have heard about the terms MIR a few times, because this is quite a hot topic in dairy industry over the past few years, not within Australia, but also overseas. So briefly, MIR stands for mid-infrared spectroscopy. And as I said, this technology has been around for some time, and it has been routinely used by the milk recording organization worldwide to quantify the composition of the milk sample, such as fat, protein, and lactose percentages. So what happened in this analysis process is that the machine will shine a beam of light in mid-infrared region, if you like, to the milk sample. And because of the interaction between different molecules in the milk sample and the light will be absorbed by these molecules at different frequency. And the outcome of this process is a series of absorbance. So if you use Bentley machine, it will be 899 wave number. If you use Force machine, it will be 1060. And however, what we can say is that these absorbance can be considered like a signature of that milk sample at that particular milking. And then, as mentioned before, we can use that to quantify not only fat, protein, lactose percentage, but what's striking is that more and more scientists and more and more research results showed that the MIR can also be used to predict other traits that indicate the metabolic status of the cows, like energy balance, metabolic health indicator like BHB or NIFA, and animal fertility prediction. That's what we Liz just mentioned, but also other environmental traits as well, like methane emissions or milk urea as well. So yeah, so that's about technology.
So you mentioned there that it's been used for lots of different things, Fong. How did you figure out that we can use this for fertility? Like, how do you know that it works? Like, do you know what I mean? Like,
Yeah, I think the fertility is a complex trait, but the health of the animals is one aspect that does affect fertility as well. And as I mentioned, the metabolic health can be predicted using MIR. So that is, I guess, the link between MIR and fertility. So yeah.
Excellent. So essentially, what you've done is you've looked at the sample, it's told you how healthy the cow is, and that tells you then how fertile she is. Is that what you're saying?
Yeah. Well, I mean, in terms of the, when the cows have after calving, for example, if she is healthy, everything is good. So potentially she's a fertile candidate compared to if the cow is metabolically imbalanced, for example.
Yeah. So Fong, something you haven't mentioned about this is the model you have worked on and to develop this and get these answers is one that is a world first. Is that right?
Yeah. So actually, the idea of predicting conception or the probability of conception to a certain insemination. So in other words, we want to see, or we want to predict how likely a cow to get pregnant if she is inseminated in, let's say, early joining period. So a few scientists in Ireland and the US have tried that before. I think it's in about 2014, just a year or 2 years before we started working, we started our projects, MIR for profit projects. But unfortunately, they only achieved the accuracy up about 60-65%. So when we started working on this, we did have to brainstorm a bit hard just to see what else we could actually do, at least in addition to their work, to make it work. I mean, hopefully. Eventually, I would say we achieved what we wanted. I mean, in relative terms. But so what we did was to, instead of training the model on the whole data set, we only focus the model on the two extreme group. So for example, the good cows, we divide them in a very good cows, I mean good categories, and the poor cow as well. The reason and the idea behind that was that to magnify the signal, so we hopefully could improve the prediction accuracy. And we saw that, and we observed that the accuracy that we achieve is about 75%, up to 75%, which you can see is significantly higher than what the US and the Irish people achieve. And I can say that we are at the moment the first in the world providing the what Dardashin terms is MIR conception report for farmers. Yeah.
That's super exciting. You must have been so excited. Were you running around the lab going, "Yay, it worked," when it actually came back as accurate?
Yeah, after many, I would say, fail attempts, that's very, very exciting.
Yeah, that's fantastic, Bong. So in 2020, you did talk about this technology or this model and how it is being used. I'm sure you didn't spend lockdown making sourdough and gardening like lots of people. What has changed since 2020, or what have you been working on since 2020 with this model?
Yeah. So seeing the last webinar, the first point that I want to mention is that MIR model is just similar to other types of model. I guess you all are familiar with the genomic prediction model. It needs to be updated to be more relevant with the current situation. And this is actually particularly important for the case of MIR. The reason why I'm saying that, because MIR is strongly affected by management and feeding. So if you change those, everything would change. So the system, the model need to be updated. So I've been regularly looking at the new data set. So before the data came to me directly, I would say in the research phase, the data came to me directly from Heritage Center, but now it changed to Dardashin. So the data came to Dardashin, and then whenever I need the data, I just request it. But anyway, come back to the point. So when I started working on this, the reference population was just 7,000 record, showing good result, and we increased up to 19,000 record by the time that I talked to you or 2 years ago. A few days ago, I just checked. We are now standing at 100,000 record, and I get with the recent launch of the data extraction project from Datagene. So as I said, the MIR data now is stored at the data center of Datagene, and the data could be obtained directly from all of the machine. So I would expect the reference population's size will increase very quickly from now on to probably in the next 2-3 years.
So increasing that reference population size, what does that mean? Does that improve the level of accuracy that you will see from the model?
I would say yes, in a relative term, a bit, but the most important point when you increase the reference population is to increase the robustness of the model. When you have more data set cover the high range, the wider range of the environment, the production system, your model will be able to work in different situations. So that's the major point. But if you want to increase accuracy, the better way is to add more information. So more variable or predictor should be added into the model, or more source of information.
Yep. So when it comes to the model, is there other information that you use to help predict that level of fertility for a cow? Because I know like the ABVs, when you look at those, they have different data points that they reference. Is it similar with this particular model?
Yeah. So apart from MIR, we also use other information as well. But the reason why we call it MIR is because MIR actually contributes the major source of amount of information to the model prediction. But apart from MIR, we also include age of calving, days from calving to plant mating, milk production, as well as the days in milk at the time that milk sample is taken as well. So yeah, these are the information are included in the model apart from MIR.
So with that, sometimes things have limits, and models quite often do have limits. And what are the limits that a farmer is looking at when looking at this sort of information?
Yeah, I think there are two major points that I want to mention here, and I've been always wishing that we could improve the model if we can have based on that. So first point is that, as you know, that the model is currently doing the prediction with the milk sample coming around 30-40 days as a which. But we know that period is always a very, very busy time of the year for farmers. So at the moment, when we look at the data, sometimes the data come in a lot, but when I filter, not many of them remained during that time period. So that's one of the points, because the reason the reason why we want to make prediction that early, because we all know that the cow is inseminated for the first time on average is about 80-85 days. So we make that, let's say 30 days or 40 days, farmers still have around 6 weeks. That's great to do any action if we base on the prediction. So that's one of the points. However, I think and I hope that with the hopefully with the potential benefits of the information that is provided by the MIR tools. This is not the only one, the MIR fertility, but also, let's say, the MIR prediction of the metabolic cows and so on. It would, if the farmer can see the potential, they might change, it's certain, pros cons there. So farmer might change the habit and put more, do more frequency of testing in early. So that could be great. That's one point. The other point is that our model just make use of whatever the farmers data the farmer have on farm at the moment. We didn't request or add any other additional data. So that's why we achieve but that's already great with 75% of accuracy. we want more than that. We want higher than that. But if we want that, it's good to have additional data sources, and that's what we are aiming to do in the current DairyBio 21-26. So we are seeking more additional data in terms of, let's say, sensor. So sensor data also related to health of the cows as well. So yeah, so that's the second point we are working on to improve the accuracy of the model.
Yeah. Now you mentioned there that you are relying on data from the farmer, and that they have accurate records. So ultimately farmers need to have accurate records to be able to get good information out of this MIR conception tool as well. Is that right?
Yeah.
Yep. So one thing I did want to bring out that has happened since 2020 is it's not just here in Australia that this tool is being used. Just want to talk about what's happening internationally with the tool.
Yeah, interestingly, so firstly, taking our initial success in the MIR prediction of fertility in Australia. So we started our collaboration with Canadian through Lactanet. So what we've been doing or collaborating with them is that from our side, we share and test our MIR fertility tools, or actually the approach on their data sets, and in return they also share some sort of indicator of transition health, but that's not the aspect of your question. But anyway, about the MIR fertility, so we've been testing that. So it turned out that it's on the force machine data and on Canadian cow, and different calving system, they all have year-out calving, but the extreme data and the results, the preliminary result, look very, very promising. So we are they are collecting additional data to confirm the result. So that's one. And recently, we've just seen a published result from the Netherlands, from Wageningen University, where they also apply our approach and on Chinese dairy cows data. And yeah, they confirmed that's works. So yeah, very exciting. So that's the model actually works. Yeah.
That's good. That's exciting, Pong.
Yeah.
It's not just here in Australia, and it's exciting that it's helping drive international work as well, and helping international dairy farmers. So that's fantastic. You did point out and mention right at the very beginning, and Joe, this is where I might bring you into the conversation. You're not just sitting here listening to Fong and I have a conversation. Fertility is a complex trait, and Fong, you pointed out around feed and metabolic health and all that really does impact on a cow's fertility. But Joe, you've been working on a different aspect using this tool. How have you been using that, and what have you been working on?
Thanks, Liz, and good afternoon, everyone. I became involved in the project to have a look at some of the potential applications of the tool. And early on, back during lockdown, we had a great discussion with one of the repro right advisor groups about this. Where I've spent most of my energy is looking at the opportunity to use these MIR fertility predictions in breeding decisions. So where I sort of started with that journey was to compare the performance of the MIR fertility tool to other strategies for identifying cows that are most and least likely to conceive to first service insemination. So one of the key comparisons I did was comparing to calving date. We would expect that cows that calved earlier are more likely to get back in calf. And we also had a baseline situation where we assumed that cows were just randomly allocated to semen. And I guess the key result there is that the MIR fertility prediction did a better job at identifying cows that were most likely to calve after their first service insemination and most likely to calve overall, like after the mating period. I know without slides, we don't want to do too many numbers, Liz, but should I throw a couple of numbers at you?
Yes, I do just have one question though, before you throw some numbers at me. Did you find, because this is the thing I find quite interesting, most often when we look at a herd, everyone looks at their first calvers and goes, right, they're my most fertile cows. I'm going to breed to them. Is that what you found? Are our first calvers the most fertile? And you might be able to bring some numbers in here,
That's
Jo.
what my numbers were going to tell you. So as an example, if I identified the top 25% of cows, so based on they had the highest MIR fertility prediction, so I did that, or they had the earliest calving date, remember our random approach was like, I'll just grab 25%. So the pregnancy rate to first service, when I used the MIR fertility tool to find those cows that I thought would be most fertile, was 46%. The calving date, it was 42%. And that random approach of just grab any, 39%.
Wow. Right.
Yeah.
So that's a big difference. Does that mean now what farmers should be considering for their farm is running for places where they can access this model and get the conception tool, running it on their herd, and then how do they then make a decision from that? Like, what decisions are they making?
So I think the other thing I should point out is that the tool works in reverse as well. So it can also help identify the cows that are least likely to conceive.
Yep.
We're talking about the bottom 25%. Let's just pull them out randomly.
Yep.
The overall pregnancy rate in that group of cows at the end of the next calving season was 64%. If we picked the bottom 25% as these are the 25% of cows that calved the latest, their overall pregnancy rate was 56%. And if we picked the bottom 25% of cows based on this MIR fertility prediction, their pregnancy rate was only 50%. Wow. So the tool works in reverse as well in identifying the cows that are least likely to fall pregnant.
And that is, when you're looking at it in reverse, the lower the number, the better.
Yeah.
It sounds a bit weird.
Around.
Yeah, it is a lot to get your head around. So when it comes then, like we know the sale of sex semen has increased, it is still expensive. Are we best then for farmers to use sex semen on those high fertility cows, really targeting those ones going forwards? Like, is that the best use of this tool?
Well, I think a lot of the recommendations around the use of sex semen in cows are to use it in early inseminations and to use it in your most fertile animals. So we have shown that the MIR fertility predictions can identify cows that are most likely to conceive at first service. So one potential use is to help prioritize which cows get sex semen. And one of the things that I thought was interesting is when I used the MIR fertility tool to work out which cows got, if I had, say, 20 straws of sex semen to give out, who should get semen, or 100 straws, we could actually get a small increase in the number of heifer calves on the ground through choosing which cows got sex semen using these MIR fertility predictions.
That's interesting. In this day and age where we are very conscious about non-replacement calves and that sort of thing, is it then that you could use that reverse thinking for the use of the tool? Can you then use like your beef on your least fertile cows? Or do you just, with those least fertile cows, if you have the ability, do you just park them and not mate them if you're going to get rid of them next year?
I'll tackle the second part of the question first.
Yep.
So in terms of not inseminating an animal, the literature and all of the sort of economic modelling is that if you want to keep her as a lactating animal in your herd, you should definitely put a straw in her because the cost of a delayed lactation is quite extensive. Yep. Like it's a lot because there's flow on flow-on effects.
Yeah.
In terms of the other types of using cheaper semen or other types of semen, yeah, that's exactly what I've done. I've used a data set that had 76 different sort of cohorts of cows, and we looked at 2 different breeding programs across those 76 herds. So in the first situation, we used a combination of sex semen at first service insemination, and with just conventional semen for the other inseminations in the rest of the herd. And we considered a second breeding program where we, again, prioritized that sex semen for first service insemination. And we also had conventional dairy semen and beef semen. So because it's a computer modeling kind of opportunity, where I've got the data sitting there and I can overlay lots of different options. So I looked at how we decided to allocate the semen. Did we use our MIR fertility predictions? Did we base the semen allocation on calving date? Or did we just randomly pick and mix? Varied what proportion of cows we allocated to get sex semen for that first service insemination, and what proportion of cows we allocated to beef semen. And we know that one of the challenges historically with using sex semen is that we get a drop in our conception rate. So I also did some work looking at the impact of a drop in sex semen rates.
Yeah.
And if I was to summarize what we found, was using the MIR conception tool to prioritize cows for insemination to sex semen resulted in more dairy heifer calves on the ground. And using the MIR tool to prioritize cows for insemination to beef semen meant we got fewer dairy beef calves on the ground. Now, remember, we're trying to put that beef semen in our least fertile animals.
Yep.
So,
Yep.
yeah.
Yep.
So,
yeah.
Do you want more numbers?
I don't know. Are we going to remember the numbers, Joe?
Yeah.
Yep. Shoot. What numbers have you got?
So, in terms of what does more heifer calves or fewer dairy beef look like, we had an average group size of 175 cows, and on average, using the MIR conception tool to allocate the semen, we saw up to 4.5 more dairy heifer calves, so 5 more dairy heifer calves, and 6 fewer dairy beef calves when we used the MIR tool to allocate semen compared to just our random pick and mix approach.
That's good. And from a farm perspective, what that does is allow them greater freedom in selection and ability to improve the herd if you've got more dairy heifers on the ground. And I suppose then that leads into the question around if we're using our most fertile cows, and we've recognised those through this model and that technology, and we're breeding, say, a high fertility bull, are we improving, using the ABV for fertility and that sort of stuff? Are we improving fertility within our herd? Or
I'm sorry, Liz, I didn't follow that question.
Sorry. Can we, fertility is an issue within our Australian herds, right? So we've spent time working, we've now developed an Australian breeding value around fertility that's now available. Can we target high fertility bulls and high fertility cows and have a big jump in our fertility within our herd?
Okay, I think there's a couple of key things that we need to cover off to answer this question fully. So one of the key points I want to make is that these MIR fertility predictions are one of several pieces of information that we can use alongside other fertility indicators. So the MIR conception tool that's been released by DataGene actually lets you do that because the MIR predictions are reported alongside other pieces of information that we know contribute to an animal's fertility. For example, its fertility breeding value, its insemination record, its pregnancy record. What else is on that tool, Fong? Can you help me with what's reported?
Yeah, it has breed BPI, health weighted index, daughter fertility ABVs, production index, of course with that's the probability, days in calving, so insemination probability. There's some interpretation here about in the spreadsheet, age of the cow, and also the antibiotic treatment as well. So there's a different piece of information there.
Yeah. So as we pointed out, fertility is a really complex trait, and the MIR fertility predictions are another piece of information that can help us make informed breeding decisions.
Yeah.
In terms of, is there a link between the MIR fertility predictions and genetic selection? One of our colleagues here at DairyBio, Irena Vandenberg, actually did some work with Fong. I think, were we still in lockdown when you guys were doing that work?
Yeah, I think so.
And so what she found was these MIR fertility predictions are a heritable trait. So they have a genetic component. And the MIR fertility predictions actually had a slightly higher heritability than some of the traditional fertility traits. So that's quite promising.
That's good.
Yeah. The genetic correlation between the MIR fertility predictions and the traditional fertility traits was small to moderate.
Yep.
So at the moment, we've got a massive data set in the National Data Repository that DataGene looks after of historical fertility and calving records. The data set we've got for MIR fertility, while it's growing, it's still quite small.
Yep.
So, in time, when the because the MIR predicted fertility is based on a milk sample, we could get a lot of MIR fertility records. And then we'd be in a much better position to do some more work to look at how the MIR predictions could also be used to support genetic selection for improved fertility. But you might have to get Irena in to talk about her work on another webinar.
We'll chat after, Jo, and I'll figure that out, shall we?
Yeah.
That sounds good. We will be having more webinars. What I might do, I'm going to, if those who have joined us would like to ask a question of Jo and Fong, we'll be wrapping up probably within about the next 10 minutes or so. But if you'd like to ask a question, just pop it either into the chat or in the Q&A section in here so that we can answer the question for you. But as like this, the MIR conception tool that is part of the what DataGene offer, we probably need to just talk about there is a limitation to this in that it's only available on some machines. Now, Fong, you briefly mentioned a couple of different machines earlier. Do you just want to talk about that it's available on different machines? Oh, no, it's not available on one machine, or it is available. Would you like to help me out of a hole here, Fong, and just tell me what it's available on?
Yeah, well, thanks, Liz. I think I'm taking the jobs of Peter Finn from DataGene a bit. But anyway, come back to that point. I think I should have mentioned that before. So we've been up to now only able to develop and train the model for the MIR fertility model for the Bentley machines. So that's where we got the data. In this case, for farmer who test with Hertz Center, firstly they should check with the Hertz Center what sort of machine they're using. If they do, and I read on these spreadsheets of DataGene, it's better to talk with the Hertz Center as well to see if the report is available to them, although they say that is available on the Hertz platform. For the FORCE machine, I just would like to mention as well, we've been trying to, or wishing to have a model or test on the FORCE machine. Unfortunately, we haven't got enough data. So even with the recent launch of the MIR data extraction project from DataGene, due to some technical issue, we were not able to extract the historical data. So anyway, up to now, we haven't got anything for FORCE. So I guess probably by the end of this year, we might have some data to start working on forced machine. So anything is might come probably early next year or mid next year also.
Yeah. Well, look, you've cracked it once before, Fong, so I'm sure you can crack it for this other machine. You'll be fine.
Yeah, I believe that what we did try with the Canadian data is work. So there's no reason why it won. But as a scientist, you always want to wait until you see the numbers.
Yes, that is true.
Yeah.
So with this, the other limitation that we do need to be super clear on is that the milk sample needs to be within that first 30 to 40 days.
Yeah.
It needs to be taken then. And so that's probably something you pointed out earlier. Farmers are so busy at that time,
Yeah.
But that's 30 to 40 days for that individual cow. It's not, the average when you've carved down 1,000 cows, and you can't go, oh, well, in average, they're within 30 days.
I get the preference is 30, 40 days.
Yeah.
But the prediction can still be met later, 50 days, for example. But the closer that you go to, the average interval between calving to first insemination, the less time for you to make action. So, if you, let's say, you inseminate cow and, you plan to inseminate the cow next week, and now you got or just 2 days earlier, you got the prediction, probably it wouldn't be so helpful.
Yep. Yeah. Well, that's true. We need to have time to make decisions and make changes on farm so that people, you can get the best outcome.
Yeah.
So yes. Or you can work out which semen you need to order, Joe. Is that right?
Exactly.
Yeah.
How much beef you need to be ordering as opposed to how much
Exactly.
So yes, I don't have any questions for you just yet, but from the audience, I'll give them a little bit more time to think. I do have one other question for you. MIR, you mentioned, is not a new technology. It's been used for a whole bunch of different things. In 2020, you did mention that you were looking at it for a different traits, so predicting things along the lines of, I think it was lameness, and other work along that line. How's that going? Has it worked or?
Yeah. So we've been looking at a different choice wherever we have the data available. So we did have a bit of lameness in the last, what I said, DairyBio. It didn't work so well. Lameness is complicated. And maybe the link between, for the lameness, the lamb cow to affect milk composition is, probably it needs to be very, very severe, for example. So in that case, and also the data sets were small too, so it didn't really work well. We did have a PhD student working on MIR prediction, so pregnancy status, so more or less like a pet check. The results show okay. I mean, it's just a bit of promising, but it was not so good. So we haven't really continued those work. In one of the area, I think it is interesting to farmers, and also we are continuing working in the current DairyBio is the MIR prediction of metabolic profile, PSB NIFA, as an indicator of more metabolic health. So the results show promising. We've been validating that, but still the reference population, just about 3,000 cows, somewhere about that number within the current DairyBio, the Animal Project 3. I think we are aiming to collect up to 10,000. So I guess by that time, and even with other deeper phenotypes as well, from metabolomics analysis. So I guess that's where we are heading to in that area. And again, I mean, Irena has done some more works on the MIR predicted milk urea to see if it can be helpful as a trait for selection of, for milk nitrogen use efficiency as well.
Yeah, I suppose that is the limitation that comes with everything. All these traits that you are looking at are quite complex. I mean, if we think fertility is complex, what leads to lameness within a cow is probably even more complex. And it may not necessarily be something we can easily pick up with one simple test. I don't have any other questions for you from the audience or from me.
Liz, if I can jump in, I think as Fong indicated, for some of these exciting pathways that we're continuing to look at with the MIR predictions, like the metabolic health, part of one of our projects in DairyBio is actually building up that reference population. So for any farmers that are on the line today, there's an opportunity for them to get involved in our work at DairyBio and contribute to helping build the reference population. So I'm sure that we can arrange for that information to be sent out to everyone that's registered.
Yeah, definitely, Jo. And that's a really good point, because Fong, you mentioned the 10,000 cows project.
Yeah,
I think it's 10,000 samples, actually. I probably just said that wrong. And that is it is a way that people can get involved, contribute, find out a bit more about their herd, find out a bit more about the research that's happening and what's going on. And you're right, we will. So my plan is that we will send out a link to this webinar, because we are recording, and a link to various other the first recording that we did back in 2020, and different things like that. So we can include anything around the 10,000 samples project that's happening as part of the current DairyBio work. We might wrap it up at that, I reckon, Jo and Fong. So thanks so much. It's been really fascinating talking to you and learning about this MIR conception tool and the work that's gone in behind the scenes, because quite often people just see the end product and think it was all simple and plain sailing all the way through. But it's been really good to hear about that and learn about how we can use it, Jo, and what your work has shown us in terms of the best way to use this information on farm. So I'd like to say a huge thank you to the pair of you for your time and your efforts. All the best, Jo, as Jo is about to trip off around and do a study tour and really help improve her knowledge, and hope you bring back some great information for us and some really good learnings. Fong and I'll sit back here in Australia and be slightly jealous.
Yeah.
Yeah. But I did just, as we wrap up, this is the first of a series of webinars, and so we'd love you to get involved in the future webinars as well. So we're looking at doing them with both DairyBio and dairy feed-based projects. So next webinar will be in April, and I'll hopefully be bringing you a project that's part of the dairy feed-based program. And so, yes, information will be sent out in the Dairy Innovation News, and to anyone who's registered for that. So if you do not receive our Dairy Innovation News, please feel free to reply to my email that I'll send out to everyone who has registered for today's event. And I'll make sure you're on the email list, distribution list for that. So we will be running these every 2 months. So they'll be advertised in the Innovation News, as well as we'll put them out through different social media platforms, through both Dairy Australia and the regional areas, and we'll work with Agriculture Victoria as to putting it out through them as well, and DataGene if it's relevant for their work. But otherwise, thank you everyone for joining us. We'll let you go about your day, and we'll see you next time. Bye.
Bye. Thanks.